Assalamu alaikum friends. I hope all of you will be fine. So today's lecture is about the basic concepts of probability theory. As we discussed in our previous lecture, that I will deliver your lectures in the form of the recorded videos, and if you guys will have any questions, we will take those questions in the form of online interactive sessions. Okay, so in this course, what we will discuss all the basic concepts and theories regarding the probability theory. What is the probability? What are the mathematical models, and what are the types of the mathematical models? And then we will go towards different concepts, which are sample space, events, and counting the probabilities of different events. So let's start it. So this is chapter number 2, and I told you guys that this book contain all the basic concepts in the form of chapter number 2. So we will dive deeper into this chapter and discuss all the concepts which are listed and written in this chapter. I have told you guys earlier on that whatever I will teach you guys in this course, you have to practice it. You have to practice all the examples and go through the exercise question to grasp all the concepts which are behind the theoretical concepts. So basic probability theory, while discussing it, what is basically the probability? Probability is basically related to the chance. What are the chances of the happening of a certain event or certain action? So this is called the probability. Probability is basically the concept which is more related to the things which are random, which are called the random experiments. Basically, we have two types of experiments. The one type of experiments is called, let me draw it here. One type of the experiment is called the deterministic experiments, and the other type of experiments are the random experiments. So deterministic experiments are those which can be determined while doing it many times. Suppose you have, as the example listed in your book is that of the electric circuit. You have a series circuit, a very simple series circuit which have one resistor and one voltage source. When you apply that voltage source and calculate the current, this current will always remain the same as far as the value of the voltage source and the value of the resistor will remain same. Okay, so that is the concept behind the deterministic experiment, that the result of that experiment will never change if you will not change the settings of that experiment. You know basically that if you have performed it once, you know that you are not changing the settings, so the results of that experiment will remain same if you will perform it again. Okay, so that is one example of the deterministic experiment. There is another experiment which is called a random experiment. Suppose the very usual example which we will come towards in this course very often, and that is the coin tossing. Suppose you have to toss a coin, and there are two sides of a coin. One is a tail and the other one is the head. So when you are tossing it, you don't know whether you will get a heads or a tail. Okay, so you have tossed it and you have got heads. If you have to perform it again, then you don't know that either you will whether you will get heads or tail in the other turn. So that is basically the random experiment. Similarly, if you have a basket and in that basket you have 3 balls, and the colors of those balls are basically red, green and blue. Suppose you shake that basket and then pick a ball out of from those 3 balls and note down the color of that ball. Suppose you have got red in the first turn, then you again put it back into that basket and then shake it again, and then when you will pick a ball, you don't know whether you will get a red or green or blue. Okay, so that is basically the random experiment in which you don't exactly know the outcomes of the experiment or the other term, you don't know about it. Okay, so that is the random experiment, and that is the essence of the random experiment. So while talking about the random experiments, while talking about the random experiments, okay, wait a minute, while talking about the random experiments, we have some concepts. Okay, so I have told you that we have deterministic and random experiment. Basically there are two type of experiment, deterministic and random experiments. In random experiments we know the actual outcome which have to come afterwards, but in random experiment, with deterministic experiment we know the outcome, while in random experiment we don't know the outcome. It will change after a certain amount of time, or after each turn it will change. Okay, so while saying while knowing the random experiments, we have some things, we have some important terminologies which will be discussed now, and the one of those are basically the events or experiments. After the experiment, you have come to know that that which experiment is basically the random and which one is the deterministic. So in this section, in section 2.1, we have a topic that is basically specifying random experiment, and a random experiment which the outcome varies in an unpredictable fashion when the experiment is repeated under the same conditions. You can see that in random experiments the conditions are basically the same, but the outcome has been changing. But in an electric circuit, I have told you guys that in an electric circuit, if you have the same conditions, if you have the same setting, then the outcome will remain same. Okay, just like I have told you that you have a series circuit. Now let me draw it here. You have a series, very simple series circuit. This is basically the series circuit. This is a voltage source, a DC voltage source, and the value of this voltage source is 10 volts, and this is a 5 ohm resistor. Okay, so in this experiment what you have to do, you have to find the value of this current which is flowing from this 5 ohm resistor. So what it will be, that would be I is equal to V by R, and V here is how much? V is 10 and R is 5, and it will always remain 2. Okay, if the value of the resistor will be 5 ohm and the value of the voltage source is 10 volts, so then the value of the current will remain same. That is the example of a deterministic experiment. Okay, while discussing the random experiment, I have given you the example of a basket in which we have 3 balls. One is red, the other one is green, and the third one is a blue. Suppose if you pick a ball from it and note down the color and then shake it and again pick a ball, then in next turn you cannot determine that whether it will be a red ball, green or blue ball. So that is basically the deterministic experiment. You should have a clear understanding and clear understanding between the distinction of both of these experiments. Okay, so I think these things are clear. So now here we have some random experiments, and in example 2.1 we have all listed here that that E1 is given as selecting ball from an unconsidering ball numbered 1 to 50. N is basically a basket. Okay, Similarly, select a ball from the urn numbered 1 to 4, tossing a coin 3 times, and noting down the sequence of the heads and tails. Count the number of voice packets. Okay, counting the number of voice packets in any communication channel. This is basically more relevant to the network system simulation problem. So we are not going deeper into this problem, but we will discuss all other problems in this course. Basically, what are the applications of random experiments, random variables? You can see that your world is basically a random world. You cannot predict that what will be the weather like tomorrow, and what am I going to speak next, or what is going on in the next instance. Okay, you cannot predict it. You cannot predict it 100% accurately. So that's why that is a random experiment. You have everything is random. So that's why the applications of this course are in weather forecast, artificial intelligence, robotics, in finance and economy, and forex trading, and there are many areas where you can apply this subject. That's why this subject has got much more importance and in this modern age. Okay, that's why I'm teaching you guys this subject, and I am not till now I'm not doing all the mathematics, but these are the basic concepts which I am telling you guys. Okay, so these are other experiments which are again the random experiments. Please go through all these experiments, all these experiments which are from E1 to E14, and see that what is common in between them. The only thing which will be common is that you cannot predict the outcome of these experiments. Okay. So these are basically the random experiments. The other concept which is also very important is called a sample space. Okay, so what is basically sample space? Suppose I again talk about the picking a ball from the urn or a basket which contains 3 balls which are red, green and blue. Okay, so when you have to pick a ball, you will pick a ball. You don't know the color of a ball at one instant, but you know that you will either pick a red ball or a green ball or a blue ball. Okay, so you have a knowledge of the total outcomes. So the total outcomes in the form of set is called a sample space. Okay, so the total number of outcomes of an experiment. Outcomes means the results. The outcomes are basically the results. So the total numbers of outcomes which can occur in any experiment or in any trial or in any event is called the sample space. Sample space contain all the listed outcomes. So if I represent those, I have told you the an experiment. So if I represent it by if I represent it by u, so if for writing the sample space I have to write a curly bracket. Okay, then the experiment, then the outcomes of the experiment, which will either be a red ball or a green ball or a blue ball, and then closing it by that curly bracket. So what is this? These are the total outcomes. This can be, and you can either get a red ball, green ball or blue ball, and these are basically the colors of the ball you will get. This sample space contains all the outcomes of the experiment. So that's it. The sample space is a very important concept. Okay, there are many other experiments and their sample space are written here. In most cases, the sample space is represented as S. In most cases in this book, we will represent a sample space as S, but it is not compulsory that you will always write it as S. It can be represented by any number of it can be represented as any alphabet or whatever you want to represent it by. Okay, so now we are representing it as S. Similarly, there are many other experiments. List all the elements separated by commas inside a pair of braces. Okay, these are basically the elements which have to be represented inside the curly brackets, and these are separated by using a comma. You can see that 0, comma 1, comma 2, comma 2, 3. These are separated by the use of this comma. So similarly, if you have to toss a coin, so there are basically two outcomes of a coin. It can either be a tails or head. So the sample space will contain how many elements? The sample space will contain only two elements, and those elements would be heads and tails. Okay, it cannot be more than that, because in tossing a coin, which is also a random experiment, your outcomes will be just two. It cannot be more than those. Okay, so we are not discussing these type of sample spaces now. Okay, the sample spaces of the experiments which are given here, just like so, their sample spaces E1, E2, E3, E4, E5, E6. Their sample spaces are listed in example 2.2. Selecting the balls numbered from 1 to 50. Selecting the balls in which blue balls or black balls are labeled with 1 and 2, while white balls are labeled with 3 and 4. These are basically the this is S2 is basically the sample space of experiment 2. E2, select a ball from an uncontaining ball number 1 to 4. Suppose that balls 1 and 2 are black and the balls 3 and 4 are white. Note the number and color of the ball you select. Okay. So that is that's it. That is now represented as a sample space, which is written here. Okay. Similarly, we have a third experiment which is written there again, and in this third experiment we toss a coin 3 times, and we have to note down the number of heads in that coin, or the or we have to see whether it is heads, tails, or heads or tails in those experiments. So you can see that either it can be heads, tails, heads, tail, heads, tail, heads. These are basically the 8 number of outcomes which can occur by tossing a coin 3 times. Okay, and so on. Kindly go through kindly go through this experiment, and in this kindly go through this example, and you will see that all these are the simplified versions, or you can simplified version of simplified mathematical model of all the experiments which are listed here in example 2.1. You can see that these are written very simply. Okay, so these are the experiments and these are their sample spaces. Similarly, we have another concept which is called the event. What is the event? We have a sample space, we have some experiments. So what is the event? Suppose again we go towards the problem which we have selected for our discussion today, and that is again the basket problem, in which we have to select a ball which are basically 3 balls, red, green and blue balls in a basket. Okay, so let me draw it again here. We have a basket in which we have 3 balls. One is this blue, okay, the other one is the green, This one is a green ball, and there is also another ball which is red in color. These are placed in this basket. Okay, these balls are placed in this basket, and you have to pick a ball. You just shuffle these three balls and pick a ball from this bucket. Okay, suppose you pick a ball from this bucket and then note down its color and then put it back. So picking a ball from this urn is called the event. You can okay, you can see that just I have picked a ball, noted down its color and put it back into this bucket. So that is a one event. Again, when you again select a ball out of these three balls and see it, this is the second event. So as you do it, that thing is called the event, and events are the basic building blocks of any probabilistic or random experiment. In any random experiment, you have to observe the outcomes by performing the event. After the event, you have to see that what has occurred and what didn't occur. Okay, so what is the event here? Picking a ball. Similarly, when you toss a coin, two-sided coin, then when you toss it once and see whether it is heads or tails, this is one event. Okay, so events are basically the any outcome you get out of any experiment. That is the event, that certain event has occurred. So that is the basic definition of the event. I hope you have understood it. So again, in example 2.3, you can see that these are again some experiments in which some events are listed. And what is basically the sample space? Sample space contains the results of all the events which has been done in an experiment. So suppose E1 is the any one number balls are selected. You have a sample space in which you have all the balls. You have a sample space in which you have an urn in which we have all the balls numbered from 1 to 50. And what is the event? The event is that you have to select a ball which is even numbered. So what are the even number balls? Those are 2, 4, 6, 8, 10, 12. These are basically the balls which are numbered as even. Similarly, you have to, in experiment number 2, where we have 4 balls, out of which 2 are black, 2 are white, while these are numbered as 1, 2, 3, 4. 1 and 2 are black and 3 and 4 are white balls. So what is the event which you want to find? And that event is basically the ball is white, and even numbered. So the ball is white and even numbered is just this one, 4W, and that's it. Okay. Similarly, in third experiment in which you toss a coin 3 times, so the event you want to see is that all the 3 experiments has the same outcomes, and it can only possible if all the 3 are heads or all the 3 are tails. Okay. Similarly, there are A4 and A5. You can see that these are the other events which might interest you. You can go through these events as well. Okay, these are up to E14. So in this book, you can see the strategy here. In example 2.1, they have formulated a sample space. In example 2.1, they have formulated a random experiment. In example 2.2, they have formulated or made a sample space for that random experiment. And event number 3, you have the event. Okay, so these are basically the events which are specific. These cannot be always these events. The event can be anything which you require. Okay, you just like you can see that the event can also be like that all the balls from number 1 to 10, or all the balls which are numbered lesser than 5 or lesser than 10. This can also be the event, or this event can be all the balls which are black in color. So that would be 1B and 2B. Similarly here, all the tosses which give you one head. So one head would be heads, tail, 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 heads, tails, head, heads, tails, and so on. Okay. So sorry, I think I have made some mistakes. One, if you have one head, so that would be heads, tail, 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 heads, tail, and tail, tail, heads. Okay. So that is these are basically the three experiments which give you one head. Initially I made a mistake. So there is another theory which is related to the set theory, and these are basically all the concepts which are related to the set. That what is a union, what is basically the set. Set is basically the combination of distinct elements which are combined in a set form, in the form of a set. So in any set we will have distinct elements or different elements. So here we have Venn diagrams. These diagrams are called Venn diagrams, and we have union. This U is basically the union, and this is basically the intersection. Union is the combination of two or more sets, while intersection means to search for the elements which are in both these sets. Okay, so this is basically the concept behind the set theory. So what we have discussed in this lecture, we have discussed the essence of random and deterministic experiments, that what are the random experiments, what are the deterministic experiments. We have started chapter number 2 in which we have seen the concepts of random experiments, deterministic experiments, what are the random experiments which you can see and you can perform. These are basically those experiments. And sample space, what is a sample space? Similarly, what are the events? Okay, so what are the events? We have seen that there can be many events in any experiment. Out of any experiment you can get many events. So that's all about the basics of the probability theory, that what are the events and what are sample spaces, what are random experiments. After it, we have seen the basics of a set theory. What is a set? Set is a combination of distinct elements, and what are the operations in sets. There are basically two very common operations. One is the union and the other one is the intersection. We will discuss this more in our next lecture. Till then, you have to see all the examples related to these topics, and we will discuss your questions in the online interactive session. Similarly, I will also solve some questions in the online interactive session. Okay, so after it we will go towards the basic De Morgan's theorem and basic properties of union and intersection, which are more commonly used in sets. Event classes, what are the event classes, and we will discuss it. Axioms of probability, how to calculate the probability of the event, and so on. These are basically the concepts which we will discuss inshallah in the next video lecture. Till then, please go through all the concepts, read about it from the Google or your course book. As I told you guys that the second edition of your book is also available in the library. If you get a time, then go to the university and issue it from the central library, which is in third floor of electrical department. If you don't get a chance to go to the university, then I have also shared the third edition of this book in your WhatsApp group. Basically, the advantage of a third edition is that the solution manual of that edition is also available, and you can find it very easily over the internet. Okay, so I think it's enough for today, and I will discuss more about it in our next video lecture.